All right, we are going to look at the properties of logarithms today. And the objectives are, we're going to use the change of base formula to rewrite and evaluate logarithms. We are going to use the properties of logarithms to evaluate and rewrite them. And then we are going to use them to expand and condense logarithms. So first thing is, we talked yesterday about how you can only use this calculator to find the value of a logarithm if it's a base 10 or if it's a base e. Okay, we talked about that. Well, there's this really nice formula here that if you're going to use, you have to memorize, because I'm not going to give it to you, that allows us to use the calculator. So the log base c of u, in order to use, we're going to take log base b of u, log base b of c. In actuality, we're going to let b equal 10. So we're going to take the log of u divided by the log of c, or we could do natural log of u over natural log of c. So for example, you probably should have a calculator, yes. So to evaluate log base 3 of 16, and we're going to go to 4 decimal places, we can just do the log of 16 over the log of 3, or if you wanted, you could use the natural log. So why don't this half the room do the logs, this half the room do the natural log, and see if we get the same answer. Allie, what did you get? What'd you guys get over there using the natural log? 2.5237. So you get the same. So either way works. All right, and then natural log of 22, natural log base 5 of 22 is log of 22 over the log of 5. And you should get 1.9206. Oh, I didn't read the directions. This says use the common law. Okay. Because now the next two says to use what? Natural log, which is the same two problems. So we did this one already. This one here, we're going to use the natural log of 22 over the natural log of 5. Questions on using the change of base formula And you can either use log or natural log, either way works. All right. And what we're going to look at is these properties, and we talked about the one just a little bit yesterday, basically talked about it in passing. We have, it says, remember in lesson 3.2 that when y equals log base a of x, x equals a of y. Since the log function with the base a is the inverse of the exponential function with base a, it makes sense that logarithms would have properties similar to properties of exponents. So if we're taking log base b of u times v, then it's called the product property, is going to be log base b of u plus log base b of v. So we can log each one of these individual factors and add the product, or add the logs together. If we're dividing, we're going to take the log of the numerator minus the log of the denominator. So this is what's called expanding. Going from here to here is expanding. Going the other way is condensing, writing it as one log. Then the power property says if we have log base b of u to the n, this is what we talked about yesterday, and I said, remember from Algebra 2, we can bring the exponent out in front and then take the log of this. So what we're going to do here, example 3, any questions on those properties? Is I want you to rewrite the natural log of 10 using ln of 2 and ln of 5. So 10 is what? How can I write 10 in terms of 2 and 5? 2 times 5. But I want it in terms of ln of 2, ln of 5. Well, this is 2 times ln of 2 times 5. We can use this product property. It says, well, it's the same as the natural log of 2 plus the natural log of 5. Let's verify that that's true. Natural log of 10 is 2.3025. Natural log of 2 plus the natural log of 5 better be the same thing, and you can see that it is. Questions on that one? Okay, let's look at B here. While we're dividing, it's a natural log of the fraction 5/32. So I can expand that by doing what? What's that? The fraction. Subtraction, thank you. So it's a natural log of 5 minus the natural log of 32. I have the natural log of 5, so I don't have to change that anymore. But I need to somehow write this with either a 5 or a 2. (16 times 2). 16 still isn't 2 to the 5th. 32 is 2 to the 5th. So this is natural log of 5 minus natural log of 2 to the 5th. And what do I do with that 5?
Bring it up to the front.
Bring it up to the front. Is my pencil sharpener not working? Oh,
I was just checking.
okay, this. Oh, okay. There's those back there.
Yeah,
Thanks. But you can still charge yourself.
I'm not sure it's charging.
So we can bring the 5 in front, and it'd be natural log. So it'd be natural log of 5 minus 5 natural log of 2. Everything now is in terms of natural log of 5 and natural log of 2. Questions there?
Do you want the answer to that?
Right here.
Oh, that's the answer.
That's the answer.
There's quotient property.
What's that?
Is that the quotient property?
This was the quotient property going from here to here. This was just rewriting. And then this last step was the power property. Find the exact value of each without the use of that calculator that's sitting on your desk. How can I write 5 square root 7 and get rid of that square root symbol? The 5th root of 7. 7 to the 1/5. Then I believe from yesterday's property, what does this equal? 1/5. From yesterday, the log, if the two bases are the same, our answers are exponents. Okay, what's the natural log of e to the 12th? What's the base on natural log? Its natural log base is e. Log base 10 is just where we write it, just log of x. But if it's log base e of x, we write it as natural log. You guys can't see that. And so if this has a base of e, what's the answer? What's natural log of e to the 12th? This one's 12. What's natural log of e to the 5th? 5. And so we get 17.
So they just cancel.
Just cancel out. And those are from yesterday. We had these properties right here. The natural log of e to the x equals x. And we have the same properties somewhere for logs. Right here. Same properties for logs. Log base a of a equals x. So these are the properties from yesterday. Right, example 5. Expand each. Means I want to write it as big as I can. So log base 3 of x squared times y, what property will I use to start expanding this? the product. And what are we going to do with each of those factors? We're going to take the log of each factor and add it. So we've got the log of 3 plus the log of x squared plus the log of y. Can we expand it in even more? We can move the 2 in front. Questions on A? B, natural log of the square root of 4x plus 1 divided by 8. What am I going to do with the numerator and the denominator? Subtract them. Now this square root is the same as taking 4x plus 1 and raising it to what power? Half. And can I write 8 as a base, something raised to a power? 2 to the third. And now where do the exponents go? Out in front. Can we expand it anymore? Can we expand this natural log of 4x plus 1? Are you telling me no? Or are you telling me yes? Who says yes, we can expand it? You guys are good. We can't expand it because it's not times, it's plus. So that's our answer. It's expanded as far as we can go. All right, what are we going to do with A? What are you going to do with the numbers out in front? Make them exponents. So this is going to be log of x to the 1/3 plus log of x minus 3 to the 5th. Now what can we do? Do what?
Make x to 1/3 the cubic root of x.
We can do that. At the same time, what else can we do? Remember, our goal is to write this with one log. We can combine them by multiplying. So 1 log, the 3rd root of x times x minus 3 to the 5th. And I like to put brackets here so that I know for sure that my readers know that I'm taking the log of that whole thing. Then B, what are we going to do with those exponents? Put them in front. Or I'm sorry, they're already in front. We're going to take the numbers in front and make them exponents. Now what? You're going to divide them. So it's a natural log of x minus 4 to the fourth, all divided by x squared. Careful on C. What's the first thing you're going to do?
Fit through all of it.
Do what?
Fit through all of it. Take a fifth root of all of that.
The fifth root of all of it. Can we take the fifth root of all of it? This is where I said be careful. Because it's only, see how this is 1/3 is in front of the log in A and 5 is in front of the log here? 1/5 is not in front of each one of these. Okay? So, yes.
Can you like the logarithm here cancel it? And then still leave like the x minus 2. And then bring the 1/5.
So tell me what you want to do again.
Like cancel the log of 3.
This log and this 3.
Yeah, and then the other log and the 3.
How can I cancel them? You just want them to go away and it'd no longer be a log problem?
Yes. Yeah.
Sorry. It's not so easy. It would, if this x was a 3, it would go away here, become 1, but it wouldn't here. The bases have to be 3. But inside here, what can we do first? We can simplify it by writing it as 1 log. Log base 3 of what? X times x minus 2. Now that 1/5 can now be brought up here to the 1/5 power. And so log base 3 of the 5th root of x times x minus 2.